Yeah, so week 9 live coding problems are available on your portal. So this time two problems are first and second problems are new. So actually this type of problem can be a part of your final programming exam. So just start from the problem 1 and check that what you are getting by this problem. Just read the problem statement and tell me what you are getting by this problem. This is basically a debug type of problem.
So this time we don't need to write the code. We have to give input to this code.
Yes. So for this,
check.
For this problem, so there is one incorrect code is given for a maxVaid. So problem number 1, there is one maxVaid function. So this is there is some mistake in this code. So you have to identify that by what are the mistakes and just provide the input for this function. So just for that input, this function should return the incorrect output. Most of the input, this function will return the correct output, but there is some corner case inputs. For that, this function will return the incorrect output. So you have to just input that input.
So we have to identify that input for which the function will return incorrect.
Output, yes. So this is the simple function. So where we are finding out the maximum value of the list elements. Okay, so always the maximum element should return. But some incorrect syntax or incorrect logic is inside in the code. Just identify the code, identify the mistake, and just provide the input for which this function should return the incorrect output. So no need to write any code for this program. Just provide the input in line number 5. It's like that. Maintain the indentation of the function and L equal to like this. Just provide the input list here. So if you provide any input for this code, for example, so if this bad function is returning the correct answer, so that means your input is not correct. So you have to provide the input for which this function should return the incorrect output. So for example, here, so I'm just providing 1, 2, 1, 2, 3. Okay, so I'm providing just the one input list and just check that this is working or not. So yeah, so this false value is meaning that your providing input is not correct for according to the problem statement. That means your problem is returning the correct maximum value for this input. Yeah. Okay, so if you found the result, so just chat to me, not to everyone. Okay, just send to me, not to everyone. Just just keep the time for all. Arjun, yeah, this is the correct. Okay. Don't see the chat answer. Okay. Yeah, Snehil, correct. So just test your code. If you are thinking that your input is correct, just compile and run and submit. So if your input is correct, then all test case will be passed. So there is only one public test case, and there is only one private test case. Yeah, Kamal Kasur, correct. These correct things. Mehta, yes, correct. Snehil, okay. Yeah, Kamal Kasur, both are correct. Sorry, Mehta, okay, Mehta. Yeah, Jay Mehta, this is correct input. So this is the debug type of person. It can be asked. This type of person can be asked in your final programming exam. But the difficulty level will be high compared to this. So this is the
So,
basic.
sir, those debug would be related to the course content or
Yeah,
algorithms or
yeah, algorithms. Yeah, you have already seen the code in your course. Okay,
Sir,
so
what do we learn by debugging from here? How is this related to this week? How is this problem related to this week? I mean, how debugging is related? I want to.
this week.
This week
So-
content, or is it just randomly they have given just two problems?
Yeah, so this week actually problems are basically from dynamic programming. Yeah, so only two problems are based on the debug type of persons. Remaining are dynamic programming based. So this is the sample where I'm providing this because of you. This type of question can be the part of the OPP exam. So you have to should aware of this. What is the problem? What's the problem? So same things. If you are getting the output input for if you are getting the result for this person, so you can just move to the second problem also. So this is also a similar type of problem. So don't send the answer to everyone now in chat box. Send to me only.
Sir, I have sent you answer.
Who is this?
Sir
Viraj.
Viraj. Yeah.
Okay. Viraj first. So have you tested by compiling or submit?
Yes, sir.
Okay, then fine. Yeah. Snail, yeah, check the logic of the code. If you're not sure, yeah, sometimes yeah, random input. So this is the small simple question. So we are the sometimes random value can also pass. Okay, Snelia. So for second problem, I've received only 3 messages. So others, are you able to solve this? Yeah, method J. And x is greater than or equal to y, but x is greater than or equal to z is not true. Okay. Yes, Neil. Correct. So -2 minus. Okay. Yep, Ross. Two, 1, 3. Arjun. Yeah. Okay, so logic is incorrect only because of that. This first if so we are using this if and else condition. So if the x is greater than y and x is greater than z, we will just assign the value maximum equal to x. But we are not testing that. Okay, so 2 is greater than, yes. Yeah, if first condition is not true, then we are not checking for the y. So y is greater than x or y is greater than z is true or not. So because of that, some input, it will return the wrong output. Okay, so this is the simple problem, a debug type of problem. Now move to the problem number 3.
So can you give the example for this?
For this max 3 byte.
Yes, sir. This one. Second one.
Okay. So I just option is provided.
Sir, zoom a bit.
Okay. So if I provided the x equal to and z equal to 3. Okay. So if we compare this 3 value by the code, so what is the condition is that, so if x is greater than y, okay, so this first condition is true. Okay, x is greater than y, so 2 is greater than y, so this condition is true. Now we will enter to the inside. So now check x is greater than equal to z. So now this x is not greater than equal to z. Okay, so this condition become false. So this is the condition if else. So we can enter in. We can enter only in any one condition. So if we have enter for the first if, so we will skip all other the elif part or else part. Okay, so if first condition is true, if x is greater than y, then second condition is not true. So what will be the our function will return maximum value which is assigned the 0. So because in last we will return the maximum. So maximum is initialized by the 0. So same value 0 will be returned by the function. But answer should be 3. So maximum value of in all these three are 3. So whatever function will return the 0. Okay.
Yes, sir. I understood.
Okay, so now move to the problem number 3. So it is also similar to your practice assignment question or same question, knapsack problem actually. So 0-1 knapsack problem. So in last session, I remember that on Wednesday session, yeah, I think Parth or I think Pras, someone saying that the greedy approach is working for the practice assignment knapsack problem. So you can also try your solution with this problem also. I'm simply I'm explain the problem statement what we are saying that. So knapsack 0-1 means there is one property 0 or 1. So we have to pick the items, but we have to always pick the complete item or we just ignore the whole item. We cannot pick the part of the items. Okay, so item have a single quantity, so we cannot pick the part of the items. So here the what is the input is. So here the first input is represent that how many items are there. Okay, so 3 items are available. Second, W is represent the capacity of our selection. So this W is represent the what weight we can pick, what weight we can select. So there are capacity W equal to 4. That means we can pick the item which have the value which have we can pick the items. The sum of the weights is less than or equal to 4. Okay, so here W equal to 4 and third list representing the weight of the item. So there are 3 items. First item have a weight 4 and the value of that item is 1 in the 4th line list. And second item have a weight 5 and the value of that item is 20. And third item is the weight of the third item is 1 and the value of this item is 3. So what item we should select for get the maximum value. So for this sample, you can directly see that if I pick the item number 1, so we can pick this item because the weight of this item 4 is equal to our capacity. Okay, if we pick this item, then we will get the value of 1. So after selecting this item, we cannot pick another item because our capacity is now 0. Remaining capacity is now 0. So for example, if we are skipping this part, skipping this value, so we cannot pick the second item because the weight of the second item is 5 and our capacity is 4. So we cannot pick this item. Same thing, say we will skip this item. Now if we pick the third item, okay, so the weight of that item is 1, which is less than our capacity, and the value of this item is 3. Okay, so if we pick this item, third item, so we will get the value 3. After picking this item, so remaining capacity is now 3, but there is no way item available of the less capacity, of the less weight compared to the capacity, remaining capacity. So we can pick only third item and we will get the maximum value 3. So this is the result. So when you finished the solution for the problem, so just send the message in chat box. Yeah, so Anushka, your approach is look like a greedy. You are following the greedy approach. So this is not a greedy based problem. So you have to apply the dynamic programming solution for this. You have to check the all pair, all combination. You cannot sort or you cannot apply this method.
But it is giving output for two cases.
Yeah, so there are corner cases and this your solution become fail because of that. So some test cases are available where the greedy approach can also work, but
So
not
this is the
always.
greedy approach.
Uh, this is not a because you are not sorting anywhere. You are just comparing the weight. Okay, just
Okay, sir. Let me see.
this is your solution. Yeah. So you are just comparing the weight value, our capacity, and just picking the element.
Yes, sir.
Okay, so this we can say that this is also not a greedy approach.
So we have to see the sum of them also, no?
Yes, some all possibility you have to check. All combination you have to check.
So, sir, if the list length is very high, then it will take too much time.
Yes, of course. So it depends on the your solution. If you are providing the dynamic programming solution, so what is the size of your matrix? For example, if you are creating the matrix, so
So
it
it
depends.
can take, no? There is no time bound, no?
No, not much. So time complexity, for example, if you are the weight, if weight value is for example, for example, 100, okay, and
No, sir, if we will see for every pair, so it will
Mhm.
take me much more time. Like for the last case, it is not running. This code is not running for the case. With answer 110, it is getting the output as 91.
Okay, for publication.
Yes. So,
So
so
here the uh, so last case number 3. So only input is there are only 6 items.
mhm.
So output is not big. Input is not big here. So actually you are
Yes.
just checking the weight
Yes, only single one.
sequentially in a sequence
The sum is
sequential
not
manner.
there. Yes.
Okay. So but you are not but in the problem statement we are interested to finding out the maximum possible value.
Okay.
We are interested to maximum possible value, not the weight. Okay, so you have to check that which have the maximum value
Yes.
and select first
Yes,
like
I'm
this.
doing.
So greedy approach will pass some test case, but some test case it will not pass. Also, if you are picking the highest value item first. Yeah, so Pras, you are using a greedy approach or DP?
And dynamic.
Dynamic programming. Okay, can you share your code? Two public and three private test case pass. Oh. So how many public test case? Three public.
Sir, would making a matrix in this case help in this question?
Yeah, so you can make the matrix. Okay, I'm just telling you. So what is the weight? So weight is 4. So you can take the 5 columns. So weight plus 1. So for example, you are taking this 0, 1, 2, 3, 4. Yeah, so you can take 5 columns. Similarly, there are n items. So you can make the row n plus 1 rows. So for example, similarly, so 0, 1, 2, 3. Okay, and you fill the complete matrix by 0 initially. Like this. And this is representing the weight. So this is the for the weight, and this is for the our items. Okay, so items. Yeah, so this one is representing the first item. So for we can also retain the value and weight for here. So what is the value for here is 1. This is also value 1 and 20 and 3. Okay, corresponding. Same we can also write the weight also 4, 5 and 1. So basically this is the matrix size. We will take weight plus 1 and number of items plus 1. After that, you will start from the this position, filling by this position. Check that what is the weight capacity. So the weight capacity is for this cell is 1. Okay, so you will check that what is the first item value. What is the first item weight? So check that this item is weight is 4. So check that this weight is less than this weight value, column value. If this is less than, then you can select it. Otherwise, you cannot select it. Okay. So for this value, you cannot select it because the value of 4 is greater than this capacity. Then you will select the value of the previous value. You will put the value of previous value, previous left value. Same things we will check here. Now the capacity is 2 and our weight is 4. So we can also not select this 4 items because capacity is less. So we will pick the previous value and then put it here. Same things here. So 3 is also less than 4, so we cannot pick. So we will put this 0 value here. Here now we will check that. So now capacity W is our is less equal to for our item 1. So here we can pick this items. Okay. So capacity is equal now. So if we pick this item, so we will take the value. What is the corresponding value of that item is 1, and we will store this one value here, because there is no remaining capacity after selecting this. So now capacity, maximum capacity is 4 and item is also 4. So there is no remaining capacity after selecting these items. So we will put the value 1 here. Okay. Similarly,
Sir,
we will repeat.
So
So we-
can you erase that and put 1? It
Sorry?
becomes- Can you delete that zeros and put 1 instead?
Yeah, 1.
You can delete everything because we know that everything is going to be 0, right? So wherever we are putting the new values, we can.
So you have to design first the induction formula for that, how you are putting these things. Okay, so I'm just putting that this value 1 here. Okay. So
Sir,
now
can
we'll,
you-
yes,
so can you tell why is it 1 again?
because here we have to check that. So now for this column, so the capacity value is 4, and we are just filling the value of first row. We are considering that we have only 1 items now. Okay, so for this row, so we are considering that we have only 1 item. So for this capacity, this 4 capacity, we can pick it because the capacity and the weight of the item is same.
But why can't we pick 3 too? Because like the capacity and weight is like lesser than.
No. For this row, I'm just considering that we have only 1 item. When we move to the second row, then we will consider that we have a 4 and 2 item now. Okay, we are starting from the sub problems.
No,
So
but
this
like,
matrix is filling like in that we are starting from the sub problems. So we are just filling the first row. That means we are considering that we have only 1 item now. So first value, this is the initial value, though this row and this row, this is the initial value. We are filling from this column. Okay, so this is the first capacity 1. So for this capacity W1, we cannot pick item because the capacity weight is greater of our capacity. Okay. So because of that, we will put the previous value. We will put the previous left value and just store here. Okay, just complete the solution, and then you can get the idea of this. Okay, so now we are picking here. If we are if our capacity is 4, and our selecting our item weight is also 4 or less than. So we will check that what we will do in the less case. So I think less is okay. Okay, start. So we can pick here. If we pick this item, then we will get the value 1. So we will put the value here 1. Okay. Now move to the second row. Now we will start from here, this point, which is I'm erasing this. So now capacity is 1, W is 1. We have a item, second item. Okay. So we cannot pick because the weight of the item is 5. So we will put the value 0 here. Okay. Same things for the second column. Now capacity is 2, and our item weight is also 5. So we cannot pick also 0.
So for all the following. 0.
Okay.
Yes, sir.
So for 3 also, the capacity is now 3. Now our weight is 0.
5.
So yeah, weight is 5, so we cannot pick. Same things here now.
Here also we can't do that.
For the complete row,
4.
it will be 5, 0.
Completely it will be 0. 0
Uh,
again. 0 or 1, sir?
hmm?
Here.
0 because weight is 5 now.
Yeah, okay.
No, but we are considering the record of previous one also, no? So because of that. So if we are filling this, okay, I'm just writing the inductive formula. What is the inductive formula? So yeah, we will pick the previous value. So here the capacity is less than our item weight. So we will not. So we will put this left side value here 0 1 second. Okay, so second row will be completely 0 by 0. Now we will start from the third. Okay, so now weight is 1 and whatever capacity is 1. So here the now our capacity is equal to our weight, so we can pick. We can pick the item, and what value we will get 3. So now this is 3. Okay, same
Yes,
thing. Now we are receiving the we are now capacity is 2, and we have an item. Okay, 1. So we have to mention that because we can this is the only single item. Okay, so we have to put the max value of in our formula. So if we are receiving a value from here, and what is the value here, and if we pick the item for that here, so what is the maximum value after summing?
3.
So yeah, this is also 3. Okay, so what is the maximum value of this 3 and this 3? So we will pick once again 3 here, and same things for here. Now we can pick
3 again.
once again. We will put the 3, and now for the capacity 4. No, if the capacity is yeah, the capacity is 4 and item value is 1. So we will just pick 3 here also. Okay, so after completing after filling this matrix, we will return this corner value. It will return the maximum value. So I'm just pasting the inductive formula now.
Sir, I did this recursively and I'm able to pass all the test cases.
You have completed the problem?
Yes, sir.
Okay, good.
Sir, I'm recursively checking all the possible subsets.
Oh, you are recursively tested.
Yeah.
But is it a okay solution, sir? Is it a good solution to do that?
Recursive solution.
Hmm.
No, actually, because we are studying dynamic programming, so recursive will take much time compared to dynamic
Like
programming.
even for 64 items, it will take like 2 per 64. I think sir was
Yeah,
mentioning.
so here the complexity will be what are the n value and what are the w value. So n into w is will be the complexity. for this.
So yeah, whoever did it with the recursive way, it's better that you try it.
No, recursive is not better because the cost of the recursive call is high.
Yes.
Yeah,
So
yes, sir.
try to solve it with this way, bro. Dynamic programming.
Yeah. So this is the actual inductive formula for this for filling this matrix. Okay, so here we are getting this max value. Okay, so this value is a list for we have received in the input, and this weight is also a list.
Sir, zoom in a bit.
Okay, I'm just checking how. Yeah. So if weight of I minus 1, so here we are reading the weight from the weight list which have received in the input. So this weight list is the input. Okay, and this value is also our input list. So we will select when the weight is when the weight of our item is less than or equal to our capacity. So this is representing the column in our matrix J value, and I value is representing the row value. Okay, so J, if the weight of our item is less than equal to our capacity, then we will use this formula, this inductive formula. Max value of our so this is the last filling value on the left side, and this is the current value, current column value which we can select.
So
Sorry.
can I request something? So the
Yeah.
previous, we had taken example of that 3 values, right, earlier.
Mhm.
Can we take some other complex example? Not so many numbers, at least some complex, because it seems, see, only one
Yeah.
value, right?
Yes, yes. So what happen if 2 item is selected? No?
Yeah. So may I give you an example for that?
Okay, so I think in test case, is there
So third one, yeah.
third one, the weight value is 10. So now the column becomes very high. Okay, just take in one random example and
Okay.
put the
Even
value.
previous one had the same kind of thing, but I came up
Yeah.
with a.
So
So
we
same
can
thing.
take
Okay.
the test case because the weights are high, so it will not become a big problem.
Okay, I'm just taking that a new list. So weight is not a problem here. So we can put the same weight 1, 2, 3, and 4. Okay, so we are considering that our W is 4. Okay, so W equal to 4, and we are considering N equal to 3, and we will just reduce the weight of our items. Okay, so we are considering what is the value of our list. So this is the value, and this is weight. So for example, we are considering that we have a, so weight is 1 and the value is 1. Sorry, value is 1, and weight, second item weight is 2. Okay, and value is 20, and third item value is example 3, and weight is 15. Okay, so in that case, I think
So here also the
yeah,
maximum
so,
weight will be 1.
yeah, 2
right?
item will be selected. So any 2 item maybe. So what will be the answer?
Just
here?
1 and 2, right?
Yeah, so 1 and 2 item will be selected. Okay, so just fill that accordingly. So 0, 1, 2, and 3.
Shall we keep the weight as 5? I mean, the allowed weight as 5.
Weight for which?
Allowed weight, if we're taking it as 5, then we'll have some different good combinations, right? So 1 and 3, 2 and 3 could.
Okay, no
Allowed
fine.
weight, yeah, I said.
Yeah, so I have increased one column now. So okay, now we will start from here. So we will put the 0 value in every single columns. I'm not filling the completely, just border.
Yeah.
Okay, so now the value we have, and we have an inductive formula, if you are able to see in the top up. Okay, so we will check the weight of I minus 1. So we are starting from this column. Okay, so this is the position we will start. So basically there we will take a loop. So we will take for 1, 2. So how many columns are there? So 1, 2. So W, W plus 1. Okay, yeah, W, we can write the W. Okay, same for J. So we can use the loop J 1 to N. Now we will start from that. So what is the value of I and J for this column? So I and J value is 1 and 1. Okay, so for one row and one column. So we will check that what is the I minus 1. So we are reading the value from weight list. So this index is now 0, 1, 2. Because of that, we are using this I minus term.
Okay.
Okay, so 0, 1, 2. So I minus 1, because we are filling here. So I minus I is 1. So 1 minus 1 is 0. So now we are considering that we have a first, we are considering the first, we have a one item which have the weight 1 and value is 1. So we will now condition is true. This is now this is the capacity. This is the capacity. Now capacity is 1 and weight is also a 1. So the condition is true. Now we will use this inductive formula. We will select the max of what is the value of the left part is. So we will take this value I minus 1 J. Okay. No, so this is not this. So I minus 1, that means we are receiving this value. st I minus 1. So we are moving to previous row value. What is the value? And what is the new value? So value of I minus 1. So value of I minus 1 is this 1. Okay, so 1 plus st of I minus 1. So st of I minus 1, this is the first index. So st 0, I minus 1 is 0. And we will check that after taking this value. So what are the remaining capacity now? So we are just taking this second index as j minus weight of I minus 1. Okay, so j is 1. Okay, we are selecting the item. So what is the weight of I minus 1 is 1. So this is the weight. So what is the 1 minus 1? What is the remaining capacity? 0. So we will check the value of for the previous capacity with 0. So this is the field st00. Okay, so we will pick this value, and 1, this is the previous value, 1 plus, now this is 0. Okay, and what is the second value is 0. So which is the maximum is 1. We will fill 1 value here. Okay, same things we will check for the second now. I value is 1, j value is 2. Now capacity is 2. So now the we are considering that the first item, now capacity of first weight of the first item is less than the capacity of our this value j equal to 2. So once again we will move to the this first condition. So stij, so we are filling this cell value. So what is the max value of this first so the value of I minus 1. So same thing for the first row, always the item is the first. So the value of the first item is 1 plus, and after selecting the first item, what is the remaining weight? So yeah, so as this is st, and first index is I minus 1 0. So we will check the previous solution. We are just getting the previous solution. And what will be the second index? So second index will be j minus, what is the value of j 2 minus weight of I minus 1. So this is 1. So 2 minus 1 is 1. So we are receiving the solution of previously calculated value from here. So this is the 0 and 1. So this is the solution for here, from here 0, 1. And what is the previous value is st I minus 1 and j. So this is the previous value. We are receiving the same value from here. So 1, because this is the only one item. So same things, this value will be put, maximum of 1 and 1 is 1. So same thing, 1 will be considering here. So same things for the third case. Item capacity 1 is less than this 3. So same formula will repeat, because the previous value is now 1, and new calculated value is value of I minus 1. So value of I minus is 1 plus, now st is 0, and now this value become 2. So this value we have received from here, because this is the 0 item. So there is no value for this here previously. So we are receiving as a 0 value from here. So 1 plus 0, now 1. So both value are 1. So maximum is 1. Similarly, we will fill this and we will fill this. Okay. So now this is the first row. We are considering that we have only one item till now. Now when we move to the second row, so that means we have now 2 items. So for this column value, now I value is 2. Just wait. So now I value is 2. So we are calculating the value of I2 and 1. Okay. This is the column. Now check that. So what is the weight of the second item is now I minus 1. So 2 minus 1 is 1. So what is the second item weight is 2. Okay. So we can not pick for the first column. So the capacity is 1 and item value is item weight is 2. So we cannot pick. So this condition is not true if we will move to the else part and directly fill the value of left value, this value. Okay, so this is will be becoming 0. Okay, now we will calculate the S to 2. So now capacity is 2 and weight is also 2. So we can select, that means this first condition is true. Now we will check that what is the previous STI minus 1 value. So this is the value 0. Okay, and so one value we have 0. Now second, what will be the second value is? So if we select the item, so what is the value of second item? So second item value is 20.
20.
So now 20 plus, and what are the remaining weight? What are the remaining weight if we select this item? So our capacity is 2 and weight is 2. So there is no remaining weight. So that means we will pick as I minus 1. So I is here 2, 2 minus 1, 1, and remaining is 0. So 1 and 0 combination. So this is the 1 and this is 0. We will pick 0 here. So 20 plus 0, now 20. So what is the maximum value is now 20. Okay. So next, now move to the third here. So now capacity is 3. If we pick this item, so this is the left value. Now we'll select 20 comma. So if we select this, this is the capacity 3. If we select this item, we will get the value 20 plus. Now what is the remaining capacity now? So 3
1.
minus 2, 1. So now we will check the solution of for 1 and 1 here. So now what is the value of 1, 1? So 1 and 1. This is the 1. Okay, so this value will be added in the previous solution. So now it become a 21. So what is the maximum value of this? 21. Okay, so now in this value, both items value are added. Same things. Once again, we check the now capacity is 4. Okay, so capacity is 4, and if we select this item, so what is this is the 21 value. If we select this item 2, so we will receive the 20 value plus, and if we select this value, so the remaining capacity will remain the 2. But we cannot pick again because the item quantity is only 1. So we can just pick only the previous item. So the formula is S 1 and 2. So the value of this item is also a 1 and 2, 1 and 2. This is also a 1. So it will remain the maximum 21. Same thing here, it will remain the 21. Now the third column. So this is the our weight. We cannot pick this weight because the capacity is 1. So this will remain the 0. Same things. Now capacity is 2 and our weight is 3. Cannot pick, so remain 0. Now here 3. So capacity is 3 and weight is 3. Okay, so we can pick the complete item now. So what is the previous value is 0, and what is the new value is so what is the value corresponding value is 15, and plus this 30 ST. So I, what is the I? 2 minus 1 1. Sorry, I is now 3. This 3 minus 1 is 2. And after picking this complete with 3, or capacity is also 3, so remaining is 0. So we will pick the 2 0 values. So 2 0 value is now 0. So it will maximum value remain the 15 here. Okay. So Same thing. Okay. So if we select the 4 capacity now, okay, so left value is 15, and what will be the new value is so new value will be value of the this item is 15 plus ST 2, and what will be the remaining capacity after selecting this? So 4 minus 3 is 1. So we will check the this one combination. So 2 1. So what is the 2 1 value is? 2 1 is 0. 2 1 is 0 I minus 1. Okay. 3. Our capacity is now 5. So, so 1 is okay, just catching that this is the 2 0, not 2 0 is 0. Okay. So it will remain the 15. So okay, after last picking, so 3 now 15 more 15 plus ST.
Sir, this 2 1 value, 2 comma 1 value will be 1, I guess.
Yeah, I also feel this.
Because sir, in the else, it will enter in the else part. In the else part, we are selecting ST I minus 1. So I minus 1 is 1 and J is 1. So we have to fill 1 comma 1 value here.
No,
So
actually
2 comma 1 will be.
capacity is 1 now, and here we are moving that 2. So second item weight is 2. So this first condition will not true.
Yeah, so that's what I'm saying. It will move to the else part.
Yeah, move to the else part. Okay. So I minus
sir,
1. Okay. I minus
yeah.
1. Okay. I minus 1 is this previous. Okay. So it become a 1. Okay, so yeah, this is the wrong. We have put the value wrong. Same thing I think we have been here now 3. So for this 3, okay.
We have to fill 2 comma 1, so it will be 1.
Yeah,
So 3 1 is also I think wrong. So
Yeah.
this value, so 3 1 now this become 1,
Yes.
and this is also I minus 1. Now this is also to I minus 1, so 3 20. Okay. So ST I minus 1 is 2 and J. So J is okay. So now this value will come here 20.
20. Yeah.
Same. Or now here, okay. So here max of 20 and 15 is
20.
I minus 1. Okay, I minus 1. J. Okay, so it will remain 20. Okay. Same things for the 4. If we are picking 4, so just wrong things happen. Okay, we are starting. Okay, so this value is now 3 I3 and J 1. Capacity is not, else part is now come in picture. So ST I minus 1, I minus I value is 3 minus 1 2 2 comma J. So 2 1. Yeah, 2 1 position is 1. Correct.
Sir,
Now-
please zoom in a little bit. If you can.
Mhm. Okay.
Yeah. Thank you. Yes.
So now this column now. Okay, so value is now I3 and J2. So capacity is, yeah, so capacity is, weight is 3 and capacity is 2. So now we will move to the else part. So I minus 1, then 2 or J value is 2. So 2 and 2, we will receive 20 here. Same thing now here. So now capacity is equal to the weight. So we will move to the if condition. So max value of the value of I minus 1. So value of this item is 15 plus and ST I minus 1. So ST I value is 3. So ST2 and the what is the remaining weight is 0. 3 minus 3 is 0. So this is 2 0. So 2 0 combination is 0.
0.
So now 15, this is S. 15 and 20. So we have received the maximum 20 here. And now in the next column is this. So now capacity is 4. Okay. So we receive the value 15 plus ST 2. Now capacity is 4 and item weight is 3. So 3 minus 1, this is 1, 2, 1. So what is the value of 2? 1 is 1. Okay, so now this is 15 plus 1, 16. So now it will make, we will take the maximum 20. And the last combination. Yeah. So the value is 15 plus ST and this is value is 2. Now capacity is 5 and item weight is 3. So 5 minus 3 is 2. So we will take the 2 value combination. What is the 2 value is 20. Okay, so 20 plus 15. Now it is become 35. This is the maximum. So this will be the answer. We will return the corner value. So we can see that if we select the 3 and 2, so we will get the 35.
Sir,
Yeah.
everything is fine. Can you just the 4 blocks whichever we are going to how was this checking alone? I mean, now you have filled everything. That's okay. So can you use the what do you call it as the trace line, right? So pointer in the one notebook. You have that, right? Next to plus at the top.
Which one? This.
No. What I'm asking is that to the left of the shapes. Do you see that?
Okay.
To the left of the shapes, sir, at the top of the one notebook. It's a.
Okay. This one. This one.
Sir, it's a function of one notebook. So you're selecting the pointers, right? Can you select that laser thing to the right of it, or to the right of the pointer?
Right of the pointer.
Right of the plus, left of the shape, in between plus and shapes, at the top. The top.
This.
You see the shapes? Do you see this? See the
The
shapes?
shapes. Okay. Yeah.
Just left of this.
Can you click on that?
Just left to it.
Left of the shapes.
The left
of-
option. Left option.
Okay. 1 second. Yeah. So this is the shapes and left option. Which is the left option?
No,
Just
no.
left to the shape. Yeah, this
Oh.
one.
This
Yeah.
one.
Now you can point it out wherever you're saying. Can you click on point it? Circle something. Is it working here?
No.
Okay. Yeah. Can you just explain me that last part? So how did we get the 35 alone? I mean, how are we calculating?
Okay.
Now with your pointer, I mean, whenever you're saying this, we are not able to what? We're not
Follow
able
you,
to
yeah.
what we were pointing out.
Yeah.
So yeah, that's enough. That's enough. Okay, sir, that's fine. I mean, tell us how we got the 35.
This 35, no?
Yeah.
Yeah. So actually, we are using this inductive formula.
Yeah. Okay.
Okay. So the what is the I and J value for this column is?
I value is 3 and J value is 5.
Yeah. So I value is so we are calculating the value. I is 3 and J is 5. Okay. So this is the value. Now we check that weight of the I minus 1. So I minus 1 is the 3 minus 1. So weight of the 3 minus weight of the 2. that means we are checking what is the weight of this second index item. So this is 3. Okay.
Second index is 3, yeah, and the weight is 15. Right?
Yeah, we are
Okay.
just checking for the third item in this row.
Yeah. Okay, so
Okay, so we are just testing that the weight of the third item is less than the capacity of our so this column is representing the capacity. Okay, so 3 is the less than this 5 value now. True. So this
True.
first condition is true. Now we will enter into this third enter into the if block. So we will check that what is the maximum value of this 2 value. So there is 2 calculation inside the max part. So first, this is the one part, STI minus 1. So this I value is 3. So 3 minus 1 is 2. So ST2 and J is 5. So what is the value of 2 and 5?
2, 5 is 21. Is it?
Okay. So I think we are always receiving the value from. Okay. Okay, so we always check the top value. Okay, I'm just checking the left value always. Yeah, so STI minus 1. Okay, so I think all value is filling incorrect now.
What happens here?
No. So in last time when I compare the value of these two, so I always compare the left value. For example, I'm calculating this value. So I'm always compare this value and the second is the new calculated value.
Okay.
So this is not the correct thing. So we always compare the previous top value.
So my doubt is that are we getting 35 here? We should get 35. Are we getting it?
Yes, we will get the 35. Okay, just I'm just once again filling the last row.
Okay.
It's
So actually,
not correct.
I ran the code. I think the last row, I can give you the value. Give me 1 second.
So 1 second, this formula I confused.
Last row values are 0, 1. May I tell you the values, sir?
Yeah.
0, 1.
So this last row, na? So
Yeah,
0, 1,
1, 20,
20.
21, 21, 35. So this is
Yeah, this is correct.
because
Because
want to know-
earlier we were comparing with the left values. We have to
actually,
compare with the top value.
Yeah, top value. We have to compare the top value because this second value actually we are considering that the left part, but this is the top part actually. I minus 1 that represent the previous row. Okay, because of that this value was wrong. Yeah, this is now correct because if you are considering that this, so now capacity is G. So this is now already filled. So the capacity is for that is 1. So our item weight is now 3. So the condition is not true for first. So we will take this item top value. Okay, STI minus 1. This is the previous row value and the same column. So we will pick this value here. Okay, by this else condition. Same things for the here, not 2. Now capacity is less than this our weight of the item. So now we will move to this value here by this else condition. So this is 20. Now our capacity is 3. So if we pick the items, we will get the 15 value. So previously calculated value is 21. So 21 and what is the new calculated value is 3. So value is 15 plus. So there is no remaining capacity after selecting this. So we will pick the 0 value here. So it will selected by this formula. So STI minus 1. So this is ST2, 2, and remaining weight is now remaining capacity is 0. So 0 is 0. So 15 plus 0. Now maximum value is 21. So this is filled 21. Now second. So if we select now capacity is 4 and our item weight is 3. So we will pick the one value of the top. 21 and compare here. Now 15 plus ST 2 and remaining capacity is 4 minus 3 is 1. So what is the value of 2? 1 is this 1. So 15 plus 1, now 16, 21. So maximum is 21. And for the last value, if we capacity is 5 and weight is 3. So if we select this, so what is the top value is 21 and new value is 15 plus. So ST 2. After selecting this item, so we will remain the capacity 5 minus 3 is 2. So we will check for the 2. So ST2 2. So this is the ST2 and this value. Okay. So this 15 plus 20. Now it become a 35. So this 35 is come from here. Okay, so this is the inductive formula for that. So we can find out the solution by this.
So simply to say, if the weight is equal to or greater than the previous weight, right? So we are taking the maximum value of the cell above the current cell and compare. And what is the other thing, sir? We are comparing it. They added weight.
Yeah, so we will select the maximum value of the previously solution. Okay, and the new solution if we select the third item. So this is the solution if we are not selecting the what is the value of what is the previously value if we selected the if we are considering that we have only two items, so 1 and 2. So this is the value at this place. This is the maximum selection value.
Okay.
Okay, this is the previously solution, and this is the new solution which we are calculating from this formula.
Yeah.
And if we are selecting the third item, if we are selecting the third item and the if any remaining capacity are there, so we will select the remaining previous items also for the capacity.
Okay.
And sir,
So
what is this inductive formula doing different, like intelligently from the brute force approach? Like,
so brute force, brute force, how you can identify that, how you can make the all combination, all possibility in the brute force method.
a double for loop, and I think that would be.
Double for loop, can you solve by this only double for loop?
We have to calculate all the subsets.
What is the brute force about? Which one? You have the code? Did you try it out?
So first you have to find out the all pair of subset actually. Then you can identify the solution.
The complexity will be 2 raised to power n.
That would be 2n. Okay.
Yes, yes.
That's too much.
So like, what is like this approach doing differently, like intelligently from?
Yes, yes. So this is the intelligent solution. If you are just finding out that how you can use the solution of sub problems. So here basically we are just calculating the solution for the sub problem first, and then use the solution of sub problem to find
So
the
like,
final solution.
what is really the sub problem here? Like, can you define it?
What is the?
So sub problem here, like.
So this is the sub problem actually. If we are filling, for example, we are filling this part. So for this part, we have a sub problem. Sorry, not this part. For this part, so we have a sub problem. We have only one weight, and we have only this capacity.
One item with weight capacity of 1.
1, yeah. So this is the simple sub problem. We have only one item, and we have only capacity W is 1. Okay, same for we are increasing this part. Now we have a one item, and now we have two sub problems. Is one for the we have already calculated this part. Now we are testing for the second value. If our capacity is not 2, so what will be our solution? Same things we are increasing by
So
this.
it's like for.
So this is the maximum capacity, which is the final problem we have received. So this is the capacity given in the problem statement.
So is it like I lay down my weights in like my columns, like different how
Yeah.
like 1, 2, 3, 4, 5, and for every like for if I only pick one item, what is the maximum weight I can get? If I pick two items, what is the maximum weight I can get?
Yes, yes. So
Like that.
initially, if we are calculating this first row, that means we are calculating the solution for considering that we have only one item. Okay, when we move to the second row, so we are considering that we have not two items. And this is the column values representing the maximum weights. So in the problem statement, the maximum weight value is the 5. So we are dividing this maximum weight into sub problems. Okay, so if our weight is 1, now 2, now 3, now 4, 5. Because if we selecting any items for our capacities, capacity is now 5. If our item weight is now 2. Okay, so after selecting this item 2, so we will remain the capacity is 3. So we have to check the 3 weight also. So is there any solution available for the 3 weight capacity?
Yeah.
So because of that, we are calculating the solution for all capacity till the maximum capacity.
Okay.
Okay, so this is the formula, same thing, same problem. So now if we are moving to the problem number 4, so it is also on the same concept. Just try to solve this, where you have to write the same type of the inductive structure formula.
Sir, how do you decide like where to use matrices instead of arrays or dictionaries?
It is decided by after just identify that your problem can be solved by dividing the sub problems or not.
Sir, but in arrays and like if you keep in reference array, they're also dividing my sub problems, right? So like how do you differentiate like when to use a matrix as like keeping track kind of?
Can you give an example also, sir, if possible?
For the sorry, I'm not getting a question. Can you repeat first once? So
When to use a dictionary and when to use a matrix? So what kind of problems need a dictionary? What kind of problems need a matrix? How do we differentiate that?
okay. So it depends on our parameters given in the problem statement. So there are 2 parameters given in the problem statement. If you are dividing the problem into sub problems, so always 2 types of value is required. For first is you can divide the items into, you can divide the weight into sub weights, and you can also divide the items into sub items. So because of that, you have to take the capacity. So you have to think about how you can make the combination. So for make the combination, so there are 2 type of you have to divide the value in 2 type of combination. So for example, if you are dividing the items, so there are 3 items, you can divide the items into sub items, and same for the weight. Because after selecting the any item, so there is some remaining weights are available. So you have to check the solution for remaining weights. So you have to also divide the weights in your problem.
Yeah. Okay. So when the weights are divided and the values are also divided, we use a matrix kind of thing.
Matrix, yeah. So this matrix will consider the all possible combination.
Yeah. Okay.
So for this, I can use dictionary also.
So dictionary, how you can use?
I initialize the dictionary with a empty. Then I will go through once through the weight, and I will assign when the items are 0, 0 comma remaining weights is 0, and then I take the when weight is 0, 0 comma remaining the items are also 0, and then I can use the tuple values into inside a dictionary
Do you have any solution which you are talking about?
Can you give kind of code or something? Be better for us to understand.
Yeah.
So, and
How
I
you
use,
are managing the combination actually in dictionary?
I will share my code, sir, once.
currently, do you know? Do you have
Do you have
currently solution?
any code?
I have complete solutions for some problem.
Okay, so just try to write your code which you are thinking about it for this problem. If you are able to solve, just share with us.
Sir, one more thing. So let's say we take an example of longest common subsequence. There we just had like one array and we had to find the longest common subsequence.
No, so there are
we
there are
didn't
two
have.
strings actually.
Yeah,
There are two
sorry.
strings. Yeah.
So like there are kind of two parameters in those problems. So is that why we
Yeah.
choose a matrix there, or?
Yes, yes. So because of that, we can choose this thing.
Code in the chart is for LCS problem. Here I'm using dictionary.
LCS problem. Okay.
Okay, so LCS is least common substring, right?
List
Longest.
So okay, sorry, longest column is substring. But there, you don't have two different parameters, am I right? So you just take the permutation of the same string, I think.
You're given two strings and you have to find like the longest common subsequence or subwords between them.
Let's see. Yeah.
Okay, so this is your solve code. So LCS and P and Q. Okay. So what is P and Q? Okay, let's test it.
So, you have to call the function also.
Mhm. Q dictionary IN combination. What is it representing now? Yes, 4 value. Well, okay, I think you're mentioning the same information in dictionary by combination of the all possible combination.
it will be like matrix M cross and
Yeah, so you are using inductive structure also similar to the LCS problem, but you are storing the value in dictionary only.
yes, yes.
Okay. So
This
I
is
think
similar
it
to
is-
matrix, right?
yeah, similar to matrix, but just we are storing in the dictionary. All the information we are storing actually similar to matrix.
So same complexity. Is it?
I think complexity will remain the same. Yes, this is the complexity, and it's m into n.
Instead of matrix, we are putting it in a dictionary. That's it, right?
Yes,
That's
yes.
Total number of loops is the same.
Number of loops are same,
Everything else is same.
but
And
it
the
is
log-
difficult to understand. I think if you give this code to anyone, so I think it will be difficult.
And comment.
So there are lots of key you are using to store the elements. So how many? What is the length of the keys?
It will
Length
be
of the dictionary? I think same.
Number of letters in P into number of letters in Q.
It will be equal to the number of
35.
elements in the matrix.
1, 2, 3, 4, 5, 6, and 4.
The length of the matrix also.
So 35 key you are storing in the dictionary.
Yes, sir.
Total our length of the M and N is 6 and 4. 6 into 4 and
24.
24. We are storing more than. Okay.
How is 35? Why is it coming 30?
So I'm just use the len function to Q.
Yeah, no, that's okay. That's okay. But why
Yeah.
35? How it is going there?
Maybe he's storing some extra
This
coordinates.
is I think one. This is extra, and this is also extra. Okay. So 24 for the combination in this for loop, and
24
6,
minus.
yes, 6 plus 10. 6 plus 4, 10 is also there using this 0 value.
That is for base cases.
Yeah, this is the basis. So 10 for the base case. So now it become a 34. So still one. So remaining how 35 is there. So this is new
So, sir,
combination.
he's running the first for loop for m plus 1 times. So that is where.
Oh, okay, yeah. M plus 1 times. Now, yeah, it becomes 35. Yeah. So we are storing the every possible combination which we are storing in the matrix. Same things we are storing in the dictionary, but more than, I think, compared to matrix, we are storing the value. Okay,
So I
this
guess
is-
it will be same because in matrix also will be storing the base condition.
No, but
Like
the
zero.
no. So size of the matrix is always the m. Yeah. So m plus 1 into n plus 1. Yeah.
That's why.
That
Even-
same. It is same.
Yeah, same.
Basically.
Yeah.
7,
Okay,
5, 35.
So for this example, if 7, yeah, 7 into 5, 35. Okay, now it's the same. Yeah, this is also nice. New things. We can store the every point combination value in the dictionary.
The problem.
Hmm?
We used this method for all the problems. I also solved the LCW problem using this.
Yeah, you can use because you are storing the every combination value in the dictionary, and yeah, this is correct.
But Pras, if you want to manually keep track of your error, like if you want to debug your code, then it will be like
It
really
become
tough for you to track.
Or you can manually, you cannot manually represent the solution on paper or pen. I think it will become difficult. Okay. Okay, something is new. Nice. Okay, just try to solve problem number 4. I think the similar inductive formula will be used. Only the matrix size will change. So this is the problem number 4. Given a rod of length n inches and a list of price that contain price of all pieces of size smaller or equal to n. Determine the maximum value obtained by cutting up the rod and selling the piece. So here actually this is the n value 8. So and this is the price value for the size of the rod. If, for example, if we are cutting the rod by the size of 1 into 8 pieces. Okay, so 1, 1, 1, 1. If, for example, we are dividing the rod into 8 pieces, and every piece the size is 1. So what will be the value? Will be so 8 into 1 is 8. Okay, if we cut the rod into for example 5. Okay, so yeah, there is one example is also given. 2. This is the price of corresponding value. Okay, so first
17 plus 5, 22.
okay, So this list is representing the price. So and the index. So here we are starting from the one value. Okay, we are not starting from the 0 value here. Corresponding value. So if we divide the if we are cut the rod into size of 2 and 6, so what is the second value is? Second in value is 8. No, second is 5. We start from the 1. Second is 5, and what is the price of the 6? So 1, 2, 3, 4, 5, 6. Yes, 17 is the price of the 6 length rod. So 17 plus 5 is 22. So this is the maximum value we will get by cutting the rod.
Is this related with knapsack? Anyway?
Same inductive formula will be used. It is also similar to like this. So we have to check the all combination.
Yeah,
here
okay.
also. Yeah.
Hmm.
Just the size of the matrix here now will be 9 by 9. It depends on the n value.
9 by 9.
Yeah. So n plus 1 by n plus 1.
Okay.
Because there are 8 value, na? So if we are not cutting the rod, so what is the cost is 20.
Hmm.
So, Sunil, this inductive formula is sent to the problem number 4. Will the inductive formula be something like max value? Yes. Okay. So max of the value. What is L is here? This is L or I? Those are. Okay, I. Sum of the value at I minus j. Comma the value at no, we can not directly pick the value. We have to calculate the remaining length of the rod. For example, if we cut the rod at the size of 1, so we have to check that the remaining, what is the remaining size, the length is. So based on that, we have to decide. Yeah, so you have to check the length. If you cut the rod of the length 1, then you have to check the solution of the previous length 8 minus 1. For example, the total length is 8. So 8 minus 1, we have to check for the 7 now. Similarly, for the previous problem, where we are just checking that if the capacity is remaining or not. Similarly, you have to check if the remaining length have any solution, previously solution or not. Well, value at
Sir, can I ask a question from practice assignment that we were confused and we asked for the scores also, but we still did not get a reply.
For which problem?
Practice assignment, the MCQ questions. So can we do it now or shall we take it after the session?
Yeah, so I think you are talking about the maze problem, no?
Yes, sir. So that's kind of tricky to understand.
Yeah.
Question number 5 and 6 is
5 to 9. 5 to 9.
Yes, sir.
All are based on.
All the questions we are somehow getting it, but we don't know whether it is correct or not. It would be better if we could.
Okay, so actually this is the problem. Actually, you cannot directly find out the solution. You have to think about how you can solve this problem. Okay, so first just write the solution code for that problem using a dynamic programming approach. So if you are able to solve, then you can identify that what are the inductive structure is correct and what are the base conditions should be correct. You cannot directly find out the correct answer after just reading the problem statement and just checking the options. So this is the problem week 9.
Exam, we are supposed to do that now, sir.
No. So this is the challenge problem. So we have already, we did not give any we did not give, sorry, we will not give any this type of problem in exam. So this is the intensely give the problem in the practice assignment, because of we are giving this practice assignment.
Sir,
To
but I
give some
think it
time
is,
to yeah.
it is actually solvable by reading, because like I'm able to understand what is happening without coding too.
So
I
if you are
think.
able to identify the logic of the solution of this problem, then you can be getting the correct answer.
I think people were discussing on Discord to like that logic way.
So just try to write the solution code for that problem first. If you are able to write solution code, then you can just
I
identify the
think
logic.
the solution code is like already there in the like inductive structure is given. So
Yeah, so you
kinda have
can
to-
you can basically use this option as a hint.
Yeah.
But you can know, so if you are not able to identify the logic of the problem, then you cannot return the answer just by looking the problem statement or this. Where is this problem? Yeah, this one.
Yeah, that one, sir.
This is a actually challenging problem. So some
We don't
conditions,
be
some
anyhow-
condition.
Yeah, sir.
Yeah, some condition is given. So how the hurdle can move? If there is any block in the path, so you can directly jump. If there is only one block, we cannot jump over the
There's-
two.
We can't jump over the 2 blocks. Yeah. If there is
Yeah,
only
so-
one, we can jump over it.
So these are some constraints. According to these constraints, how you can solve this problem, how you can make the inductive structure, and how you can make the base case in your matrix, which you are assigning in the solution. So just try to solve this problem using DP method, and you can take the help of these options. So there are some so always there are correct answer is there in the options. So you can put the inductive structure, you can use this inductive structure as a condition which is given in the problem statement. So just try to write a code for this, and after that, after writing the solution completely, then you can easily identify that how the these questions are, how the answer is written. So this is the complexity. So this complexity you can directly take if you are filling the matrix of size m by n, so the complexity will be m into n. This is practice question, so answer is also available.
So can you at least just explain the last question alone? The 9th question at least.
Yeah, so what are the possibility when the SP m minus 1 and is greater than m plus n minus 2? So one feedback is also given, I think. One can jump only one hurdle, thus
Yeah.
2 row and columns. What does make subsequent cell value in the greater than into m into n? I think so. After complete solution code, we can easily, I think,
No, sir, I'm not getting it actually. That's why. This is something theory, right?
So
This
can you just try to write the solution for that?
I don't know how.
So this is simply a problem statement. You can write the solution code also. So currently I have no solution code. I've also not no solution code. So after just I will create the solution code, then I will explain. Yeah, either on Discourse or in the next live session.
This is what happens, sir. Okay, fine.
And sir, I'm not actually able to like solve GRPA one. So is there like any hint that you would?
GRPA 1,
Yeah.
week 9.
Like I'm able to solve it using brute force, but I don't know how to like efficiently solve it.
So same thing, DP will be used. You have to check the all combination, all possible combination. Are you able to construct this word or not? So you have to make the table. Same things. So how many characters are there in the input? So 1, 2, 3, 4, 5, 6, 7. Okay, similarly, like you have to make this row and make this as a column.
Okay, so matrices have to be used.
Yeah. So you have to all combination. You have to check the all combination.
Okay.
You have to put, for example, if you are taking this AP, then you have to check this AP with all combination. So if you are getting this apple or not.
Okay, thanks.
Just think about a matrix form solution. Yeah. So possibility that SPM minus 1 is greater than plus.
So at least can you help me, like, tell me if I'm going the right way to solve this question, last question.
Yeah, last question. Okay, I'm also checking that.
But the double jump here means like we're jumping over 2 hurdles, right? Like
That is not
in
possible.
array. Yeah, that confused me too. Like it was written, it is not possible, but
So m plus n. So what will be the length? There will be no way to beat the n without the double jump. So I think this value is representing that if you are getting the value in last column and last row cell, if you are getting the value greater than m plus n minus 2.
When?
Okay.
Yeah.
So this is the possible condition. It is greater than, this is minus 2. Okay.
I mean,
So
what I can say is that if you're just passing without any jump, okay. So if there is no what is that? No hurdle on your path, then you will reach in n plus n minus 2. That's something.
no,
I
so
can-
okay, so if you are starting from the 0 position, okay.
Yeah.
So you can move to the last position in how many steps you can move?
n minus 1 plus. We can go to towards the right.
So
To
n
horizontal.
plus m, n plus m, no?
n plus m minus 2. You can even calculate it, sir. Like how many things are there. So if it is a 3x3 matrix.
No. So there is one condition is also given. No? If you are jumping, then it will count as the step.
Yeah, the maximum, even if you're jumping, then the step will reduce. Right? Step count will reduce.
No,
Not
why will be reduced? I think the one condition is given.
Yes.
The task is find the least step required to reach the end of the step is jumping over one hurdle. It's considering as one step here. This is considering that this is the last line. If you are jumping over the one hurdle, then it is also considered as a one step.
Yeah. So can you tell me, like, from going from 0, 0 to 2, 0, is it one step or two step?
0, 0 to
2, 0. I mean, 2 rows down.
okay.
So is that counted as one step?
One sec, I'm checking it. Even jumping over one cut. Okay. One. Okay. What is the option?
So the answer is, except for the last option, everything is correct.
So there is a condition type.
I'm just not able to understand the first option, sir.
That is the base condition actually. The first option, okay.
Option. Not asking the first question.
There will be no way to reach the end without a double jump.
Is that option even relevant to this question? If to this question, this question.
We have to check once the correctness. What is the possibility? Okay, I will check the correctness as well as the answer description. Then I will reply on the discourse. Okay.
Okay. Mr. Bronzer, we don't get the answer PDF also, right?
No, this time we are providing the answer feedback. No? So because of that.
Feedback is fine, but with the feedback, also we are not
Yeah.
able.
Okay, I will reply on the discourse now. I am also not able to getting the exact description. Okay, so next we are taking the next column. So anyone completed the column number 4, live coding solution? similar in the last problem, we will just take the matrix of the, for example, this is the value of n, and this is the price, and we will take one another matrix length, for example, length. So we will maintain just the value of the length 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this is the possible length after cutting the rod. So according to this, we will just create the matrix. So n plus 1, we will create the matrix. So now 0, 1, 2, 3, 4, 5, 6, 7, 8. Same things for the row 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and same things now we will fill from the top of manner 0, 0, 0. Like this. So we will start from this, and we will use the same inductive formula, similar inductive formula. So like this is the inductive formula for them. Yeah. So we will check that if the length of the I minus 1 is less than or equal to j, we will find out the maximum value of the price. Else, we will select the previous top value of the solution. Yeah.
Sir, what does this if statement mean? Like if length of I minus 1 is less than or equal to j?
This
Like in terms
statement.
of the problem. Yeah, what does it mean in terms of the problem?
So after cutting the, for example, this one side is representing the size of the rod, size of the rods. Okay. So this, for example, this column row value representing the size of the after cutting. Okay, we have cut the rod of the one size.
So length is the matrix. Is length the matrix?
Yeah. So same length is the matrix. So same structure we can cut the rod. So we can cut the rod by the one size, then remaining is the 7. Okay, so we can cut the rod from the 2 sides and the remaining will be 6 in the same way. So we can create of the we can cut by the any of the size 1, 2, 3, 4, 5, 6, 7, 8 till now. So because of that, this matrix is created according to this cutting possible cutting value. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and similar to of the column value. Okay, so for example, we are starting from here, so we will check that this is the matrix, this length value we are taking from here. So I minus 1, for example, we are starting from that. So this is the value of I and j. So here I value equal to 1 and j value equal to 1. So we will check the length from here. So what is the length of here is now I minus 1 is 1. Okay, and what is the same things? This is the our capacity. We can say that this is the capacity. This is so this is the value represented if the size of the our rod is 1. This is representing the our size, total size. Okay, and this is the cutting value. So if the length of the I minus 1 is less than our rod size, total size of the rod, then we can cut the rod and we will find the price for that. So we will find the STIJ. So we will check that maximum price of I minus 1. So what is the price of this value is now 1. Okay, so we will use this formula 1 plus now STI. So STI is our value is 1, and the remaining length of the rod. So for example, if the size of the rod is 1 now, we are taking that this our size of the rod is 1 and the cutting size is also 1. So there is no remaining after cutting the size 1, there is no remaining rod length is available. So we will consider that there is no remaining. So length j minus length of I minus 1 is 0. So we will just take 1 0. So that is the represent the 1 0 value. This is this. So we will take that 1 plus 0. And what is the previously solution value is so I minus 1. So we will move to the top and j values. This is now 0. So 1 comma 0. So maximum value is 1. Yeah. So this is the problem. Here we are representing that, but where from we are cutting the rod, and this is the this is the representing that what is the size of our rod. Okay, so the size of for the first cell, the size of our rod is 1, and we are cutting. We are not cutting actually. In that case, we are not cutting, and we are considering that we are not cutting that. So the price of that this rod is what is the price of the size 1 is 1. So this value is coming here. So if we move to the second, now length of the rod is 2 and we are cutting from the 1. Okay, so now we will check that. So yeah, so 1 we will selecting that the 1 max price of the, so what is the price is 1 plus and st 1. So what is the value of 1? And after cutting the 1, what would be the remaining size of the rod is? Okay, so the total size of the rod is 2, and after cutting by 1, so the remaining size of the rod will be 1 here. So we will check the S11 value. So this is the S1. So previously value this is, so we will increase by the new price. So 1 plus 1 is 2, and so top value is now st I minus 1 and j. So this is the 0 value. Okay, so it representing that if we are our length of the size is 2. Okay, so we can cut of the this length by 1 and 1. Okay, so what will be the total price is? Now price of the one length rod is 1, and this is the 1. So 1 plus 1 is 2. So now it becomes solved till now. This position. Same things for 3. So here now we check if the rod size of the our rod size is 3, and we are cutting that of size 1. So same thing. So we have already solved the problem for the length 2. Now we will check that there is one more size now. So now previous size is 1, and we are cutting one more. So now one more. So it becomes 3. So here we are taking that if we are cutting the size of 1. So what will be the maximum value? Same things for here. Now the total length of the rod is 4. So we can cut by the one size. We can cut the rod into 4 rods of the size 1. So the total price will be 4. Similarly 5, 6, 7, 8. So this is the maximum price. So what total for the total length of the rod is 8. Now we can cut the rod by 1 length piece. So total 8 piece will be there. So the total cost will be 8. So same for the, now when we are moving to the second, so there are 2 possibilities there. We can cut the rod by 1 side. We can cut also by the 2 sides. Okay, so same possibility will consider now. So for example, this is the total length of the rod 0, and this the length of the I minus 1. So now the I minus 1, the length of this length is 2, and our total length of the rod is 1. So this condition is not true. First condition is not true. Okay, so now we will move to the else part, and then we will pick the value from the top. Okay. Yeah, so this value will be 1. Okay. So now length of the rod is 2, so we cannot divide. So previous solution will be, we will consider that. So now the size of the rod is 2 and the length we are cutting from the 2. So this can be possible. So we will just move, we will select this max formula. So max of the price of I minus 1. So I is now 2. 2 minus 1 is, this is the price for, so this is the price for 5. This is 5 is the price for when we are cutting the rod of the size 2. So 5 plus, oh, sorry,
5, right?
1 second, I'm just checking their age. So for the second column, so now we will move to the max of price of I minus 1. This is 5 plus ST of this is I. So I, what is the I value is 2, and this is after selecting the, after cut the rod by 2 sides. So the total length of the rod is now 2. So after cutting, that means we are not cutting. So there is no remaining length of the rod. So this is will be 0. So what will be, what is the value of 2 0 is 0.
Yeah.
So that means 5 plus 0 is 5. And what is the previously value calculated for this column is 2. Okay, this is the I minus 1 and G. So this is the previously solution. So 2 and 5. So we are getting here 5. Okay, so max, that means if the length of the rod is 2 and we are not cutting that, we are not cutting this rod, so that means we are getting the price. If we are selling this 2 length size rod, we are getting the price 5. So now we are moving to the 3. So for the third solution, yeah, so now I equal to 2 and J equal to 3. So same thing, so the value will be 5 plus now ST 2 and I, what will be the remaining length after cutting by the 2? So now total length is 3. Now we are reducing by 2, so 1. Okay, so we will check the solution for ST 2 comma 1. So 2 comma 1, so this is 2 and this is 1. Okay, this is the 1. So 5 plus 1. So we will get the 6, and previously we calculated value is 2. We have 3. So now we will get the maximum value 6. So that means the total length of the rod is 3 and we are cutting by 2 and 1 combination. So total cost will be 5 plus 1 is 6 now here. Okay, so same things. If we are the total size is 4, we are cutting that now. So okay, so we are receiving 5 plus ST 2, and after cutting by 2, so what will be the remaining size will be 2. Now we will check 2 combination. So 2 and so this is 2 5, yeah, this is the 2 combination. So now 5 plus 5, this is 10, and previously calculated value is 4, and this is 10. So that means if we are cutting the rod by into 2 parts of the length of 2 and 2, so we are getting the 10 value. This is the maximum. So same thing, we will repeat this matrix again and fill the all combination, then we will get the maximum value here, and we will return the solution. So using this inductive formula, just write a code.
Yes, sir. I get this. Actually. Thanks.
Okay. Okay. And the last problem is not directly related to DP. It is related to the backtracking concept. Okay. So just try to solve what are the how you can make the all possible subset of the given input. Sorry, no, this is not. Oh, this is related to DP also. Okay. Sorry. Yeah, it is also related to DP. Just try to solve using the same DP concept. This is a little bit tricky. Just try to solve, and if we are not able, then we will discuss this into the next coding session. Okay.
Now, may I give us? Okay, are we going to solve it now? Yeah. Or the session is complete.
No, if you have any query, otherwise this is a little bit tricky question. So just try to solve it first.
Okay.
So the problem statement is simple. What we are actually counting here, the subsequence is definition is given that accept a list L of distinct positive integer function return number of subsequence having product of element is smaller than k. So that means we are finding the all possible. So there is one explanation is given. So for the given input 1, 2, 3, 4, the k value is 10. So just check that how many subsequence of the elements are available. So the product of these subsequence is less than 10. So these are the subsequence possible. So 1. So we can just take as a 1, 2, 3, 4. This is as a subsequence available, and this is the next 1, 2. The product of this 1, 2 is less than this 10 value. So 1, 3, 1, 4, 1, 2, 3, 2, 4 also. Same for the 1, 2, 3. Yeah.
Yeah, in this problem, outcome 1, 2, 3 and all is a single element, right? So it's product of
What will we multiply it with?
Yeah, the same question.
Okay, 1 second. The distinct positive integer function return number of subsequent having product of element is smaller than k. So product of elements, so there is no elements available, so we will directly return the same element. So we are actually finding out the subsequence, all possible subsequence. These are the possible subsequence. So single element is also possible for the subsequence. So there is no element to multiply. So that is the.
But the product is not possible, right?
Yeah, product is not possible for the single element. There is not possible to product here.
Or maybe the question.
The definition is having product of elements subsequence function return number of subsequence having product of elements. So there is one element, so that means that the product of element is also is a 1. So function returns number of subsequence having product of elements is smaller than k. So there is a single element, so we cannot multiply by same 10. Okay, 1 second. So 3394. Yeah. So the question is correct because we are multiplying the product of all elements. There is one element that means this will return the same answer. So 1. There is no element to multiply. If we have if we have more than one element, then we will multiply all the elements. The subsequence of given sequence is a sequence that can be derived from the given sequence, deleting some or no elements without changing the order of the remaining elements. So this is the possible subsequence. Actually, one element we can consider as a subsequence. I think we should add some single line. If product is single, then that is considered as a product.
Yeah, so that should work.
That's some ambiguity is there now.
Yeah, sir.
So consider single element inside a subsequence as a product. Now, for this problem.
Sir, hello, sir.
Yes, yes, yes.
Yeah. Sir, in this problem, the question asks us to return the number while the output returns a subsequence itself.
So output is just a 9 value.
You check out the output that is given in the sample test cases, sir.
Oh, 1 second. Okay.
And also the function call is just subsequence. Well, like in the programming portion, your product count is a thing, while they call it a subsequence of L.
Yes, yes.
The value of K is also not given in that.
Yeah. So actually the problem statement and the solution code or test case are wrongly configured or mismatch actually.
Yeah.
Okay. Yeah, this is the test case for the different problem. Okay, so now
And the
at the
value
time.
of k is also not given in it. Like
Seems like the test cases are different, but question
Yeah.
is problem
No,
is
so
okay.
this is the problem statement actually, but the all this is sorted subsequently. Okay, now solution code or prefix code is also not the for this problem here. Actually, the image of the problem statement is not changed. This is okay. We will correct it after the session. And then
okay, sir.
okay, just now we are leaving it, and then I will correct it after the session, and I have to change the all test case according to the problem. Okay, so now we can close the session now. This problem statement, and otherwise this problem will not be verified by the solution. Okay, now so we are closing the session. I will correct this problem statement and solution, then re-upload again.
Yeah.
Yeah.
Yes, sir.
Okay. Yeah.
Sir,
Gokul. Yeah.
Can I give a suggestion, sir? So next live session, before coming to the next lesson, can we at least have a form or somewhere where if we have any particular doubts before the session itself, you will get, okay, this doubt we can discuss it now. So because right after coming to the session, and if you ask doubt, maybe if there is some time, you might need to go back and come back and tell again. So you get my point, right? I asked some question.
Okay, so this is actually you're talking about for the open session or the live coding session?
Yeah, that is the open session only I'm talking about.
Okay.
Coding session we can't do that because we release the questions immediately, right? Just before.
Okay. Form you are talking about, no? So
if that is something that we have, and you can check that, right? So you can prepare earlier priorly, and the live session could be going better at least. If any person is asking the same doubt, then you can say that, okay, let's discuss it now. Something kind of, you can come prepare something with the material.
Okay.
That's my suggestion.
Okay, we will try for the upcoming sessions. Yeah.
Yeah. Okay, sir. Sure. Thanks.
Okay. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you.